Hi, it's Mr. Baumann here to tell you about sea level rise, our fourth topic from our list of topics here for your research project. What I'm going to do is I'm going to go through each of these sources. I'm going to give you some information from those sources, kind of talk you through what your topic is all about, and give you some help so that you can answer your questions better. All right, here we go. Source number one is going to be from NASA. So this is NASA's climate page. You can see all kinds of good stuff on here. So right now we're in the facts section, we're in the vital signs section, we're looking at sea level as a topic. You can see there's other topics here, and if you go back and look through your topics, actually it's the first three from the project that are still listed on here. So this is the last of those topics that is covered on the NASA site here. So you can see this site's got lots of good information for you if you want to make connections, or if you want to see like evidence, causes, effects, what do scientists think, and then like look at some of the FAQ. That just might be interesting for you to check out if you're looking at it. All right, so what the heck is this sea level measurement? So what we have actually been able to measure, all right, using satellite data. So we use the Goddard Space Flight Center's satellites from NASA to kind of measure the essentially amount of water that's on the Earth, especially related to the oceans and how high they are on shorelines and things like that. We've got some really good ways to measure that using satellites, so we don't have to like go around in boats and like put a measuring stick like in the water and measure it. We can actually do that from above. So sea height variation in millimeters, which are really, really small, right? Remember, it's 10 millimeters for every centimeter, right? So that's quite a bit of them. But you can see here that our sea level has been essentially on the rise, up 3.3 millimeters per year, which isn't very much, but over the course of some number of years, right? This is from 1993 to now. But over the course of this many years, we've gone up. We're getting close to 100, right? We're 95.7 in 2019 millimeters from zero, which was kind of like where we started, right? In 1993, we started taking these measurements. So since then, we've gone up by that much, right? So plus or minus 4 that's how much error there is in the data. So not all these measurements are exactly perfect. Sometimes there's stuff that's not quite right, but that's what an uncertainty margin is. That's how certain we are with the data. So at most we're 100 millimeters above zero. At least we're 92 millimeters above zero, basically is what we're saying. But we can see that we're actually getting an increase in the amount of water in the oceans. And where do you think that water is coming from? It's coming from melting ice. Okay, so if you go and talk to the people who are dealing with Arctic sea ice and ice sheets, they'll tell you ice is melting. When more ice melts, more water is around. Okay, which isn't necessarily bad, but it is actually kind of bad, because where are we going to put our old people if Florida's underwater, you know? Think about that. So here we've got some tidal gauge records, which is also showing the sea level change in millimeters. It's actually significantly more drastic. We've gone up since the 1880s, right, where we started saying that was like our zero level where we first took our measurements. We've gone up by almost 250 millimeters, right? So this is taken on the ground, like by people measuring it physically. This is taken from a satellite. So if you want to show both of those or one of those, you could do. They both show the same thing. The sea level's rising. Okay, and if you want to know by how much, you can kind of capture that right there, right? So yeah, places like Florida, your vacation places, your beaches, they're gonna be changed, right? So you can even go out if you Google like houses in the Outer Banks. There's some houses that were streets away from the beach in the Outer Banks up like 50 years ago that are now literally getting hit by waves because that area is going away. Has to do with changes in tides and changes in sea levels and changes in lots of things. So, all right, let's move on. So that's the first topic there. That should get you some of the how. How do we get this data? Well, we collected it either by physically going out and measuring it, right, with tidal gauges, putting these gauges in the water and floating them and taking measurements, or we took it from satellites. And then what does it mean? Well, you can see the sea levels rising. How's that related to climate change? Well, temperature up, ice melt, water go up. Here we go. Second one. This is from climate.gov. It's a NOAA site here, so you can see this is a trend in global sea level. This is basically that same graph. It kind of combines a lot of our measurements here. So the global mean sea level, so average sea level, has risen about 8 to 9 inches since 1880. Most of that coming in the last 20 to 30 years. So it's mostly due to a combination of melt from glaciers and ice sheets and the thermal expansion of seawater as it warms. So the warmer the water, the more it expands, which is weird to think about, but that is how thermal expansion works. Okay, so but most of it's actually coming from melt. So if you look at the highlights here, sea level has risen 8 to 9 inches. In 2018, sea level was 3.2 inches above the 1993 average. That's the highest single year change. The rate of sea level rise is accelerating. It's more than doubling from 0.06 inches which was what it was in the 1900s, to now it's like 0.14 inches, which is a little bit bigger than twice as much of an increase in the amount of water. So many places in the U.S. you're seeing high tide flooding, 300% more, and 900% more, or 900% more frequent than it was 50 years ago. So you're going to see more places getting higher high tides, basically. So those things are all connected, really, right? So you can see that sea level is closely connected to ice melt, which is closely connected to temperature rise, which is part of what we're talking about here with climate change. So here you can see measurements made in ocean basins. These are just measurements that were physically being measured, right? Or using a satellite to measure the ones in Antarctica here. But you can see the change in sea level in those places. Most of them are coastal or out in the middle of the ocean where we sent ships, or we were measuring via satellite. But you can see changes drastically lower in some places, but usually it's much higher, right? So you can see that, and this overall ocean picture here that's colored in, that's from a satellite image as well. Okay. So in some ocean basins, sea level has been as much as 6 to 8 inches, has risen as much as 6 to 8 inches since 1993, which is pretty insane. A lot of people live in coastal areas. That's why we care a lot about this, right? So why does it matter? This is helpful for the why does it matter? Like, are you going to lose this city, wherever it might be? Looks like it's South Beach, Miami. Okay, yeah. So is that place going to be useful for tourists or at all there even? Or are these buildings going to be literally underwater or destroyed or have to get moved or whatever? Maybe, right? I mean, in a little bit, right? So here's a picture of nuisance flooding, right? This is Annapolis, right? You might be familiar with the Navy Academy. But yeah, we're also seeing higher background water levels makes deadly and destructive storm surges worse, right? So they go farther inland, they affect more people, you get more flooding, you get more problems. Okay, so what's causing sea level rise? You can see here some pictures of glaciers. This is a picture of the same place in 1917, 2005. So if you want to know more about that, you can get with the ice people, or you can go back to source one and click on ice. Just kind of look at that. So less ice, more water, right? So here's kind of combining all of that stuff to show you that the sea level is in fact rising. Some of it's from water melting, some of it's from thermal expansion, but most of it's from meltwater. Okay, and then here's some talk about the future. What does this mean for the future? Well, what could happen? We could see more of this because we're probably going to, right? So there's some talk about like what happens if the sea level goes up and how this is going to work. So, and a lot of the what I want you to do for yours for the future is kind of think about how it might affect us or how it might affect others, right? So like Ohio's pretty nice. We're pretty spread out. We don't have a huge dense population, but let's say you flood the entire East Coast. So like Boston, New York City, Miami, all those big cities like along there, Charleston, Savannah, all those cities are flooded now. Where are those people going to go? Well, they're going to move inland, right, to the higher ground, places like right here in Ohio. Which, I mean, you know, having some more people here would be okay, but we don't want to have so many more people here that it makes it hard for us all to live. That wouldn't be great. All right, next thing. So this is from Australia, and this is like kind of the Australians government's version of what we were just looking at. So here's a description of some trends, some things that they were seeing, some description of how it's working with the Great Barrier Reef, the largest coral reef in the world, what that does to extreme sea level events like storm surges and things like that. If you don't know what a storm surge is, you just check it out, like watch a YouTube video or something about that, just so you can see it. I'd rather you see it than me just tell you what it is. And then here's some effects on how it's affecting people around the actual country of Australia. So sea level is important for determining the distribution of species and habitats, which affects foraging and breeding for many, many species. So sea levels have risen and fallen a lot. That's causing shifts. That's causing things to change, right? So sea levels on the Barrier Reef have risen, right? So actually the reef needs to be kind of close to the surface so that it can be the proper climate for things that live there. So getting deeper there is actually bad. So you can see here they're talking about Townsville, not where Timmy Turner lives, but it's actually a place in Queensland, which is a section of Australia that's recording these increases, right? And then you can see here at Cape Ferguson, which is near Townsville, you see this higher increase. And they use millimeters because everywhere else uses millimeters. So small, the change is small relative to geologic history, but sea levels have been very constant for a while, and they're changing drastically now, which is a sign that there's something happening, right? So it's something to think about. So they're mostly concerned with like what's happening on the reef and with these turtles and these birds that are going to be vulnerable. So it's also going to cause, beach erosion, which is going to flood nests. Bad for all the living things. So then here's a National Geographic article. Apparently it needs you to sign up now so that you can read. That's really annoying. Put in my email address or something. It'll be fine. You don't have to use your own. or yeah, it's fine. Sorry about that. Man, I really want to see this article. All right. I'm already signed up. Yeah, thanks. Great. Awesome. All right, this article is really nice. Just kind of shows you the human effect. So here's a picture, right, in Kiribati, which you might not know where that is, but take a look on Google Maps and you'll see it's a beautiful island nation, but a lot of people are living in like extreme poverty. Just living conditions are a lot different. And if you're underwater for most of the time, that's not great, is it? So, and it also kind of makes a connection to climate change and greenhouse gases and things like that. So then here you can see this is in the U.S. We've got flooding, right? These are probably caused by hurricanes and things, but you can kind of see here's an explanation of thermal expansion, of melting glaciers, loss of ice, and then what are the consequences? So here are the things that are bad. What can we do to adapt to the threat? How can we help? How can we fix it? What can we do to cope? This is going to help with that section for you, okay? And then, yeah, there's this really good Climate 101 series you can watch. What can happen in the future is right here, and then you can kind of think about what are some things we can do based on that. So I kind of want that what do you think will happen, future stuff, and then the what can we do to kind of be reactions of you kind of looking at this information and putting it together. So that's it. I'll get out of here so that you guys have some time to work. Good luck. If you have questions, let me know.